Another tool that we can use to solve systems of equations is substitution. Substitution is a little bit simpler to do, purely based on the fact that you don't need a graph to do it. So we can see we have a system of equations above. We have our first equation here, which is in slope-intercept form, which you're going to see once we have the equation solved for a variable. It makes it much easier to do substitution. And then we have our second equation here. What we're going to do for the first step of substitution is to isolate a variable. Now, as you can see, which I was referring to earlier, here we already have my y isolated, and I have the equation y equals 2x plus 4. And what this allows us to do, since we have this y isolated, it allows us to substitute what we have for y into y in the variable, or I'm sorry, into y in the other equation. So what we're going to do is, where we see y in the second equation, we're going to plug in 2x plus 4. So I'm going to, let me get rid of some of this stuff so it's a little bit easier to see. I'm going to plug in my 2x plus 4 for y here. So I've got my 3x plus, and we're going to plug in 2x plus 4, and that whole thing is going to be equal to 9. Now if we look at this equation that we just created, we have one equation with only one variable. So it's going to make it much easier now to solve it. So I've got 3x and plus 2x plus 4 equals 9. Sorry, my equal sign equals 9. Combine like terms here. I've got 5x plus 4 equals 9. Get this alone, I'm going to subtract 4 on both sides, so now we're just solving equations, and if I bring the whole thing over to here, that's going to leave me with 5x equals 5. Divide both sides by 5 to get my x alone. X equals 1. So I solved for one of my variables. I've got x equals 1. Now what I'm going to do is I'm going to go back into my original equation where we solved for y, and we said that y equals 2x plus 4, and I'm going to plug in and evaluate with the variable that I just solved for. So again, we said y was equal to 2x plus 4. We knew that because the problem gave it to us in that solved solution. If x equals 1, I'm going to plug 1 in for x up here. So y equals 2 times 1, which we just solved, plus 4. So I got y equals 2 plus 4, and we can finish that off by saying that y equals 6. So I've got x equals 1, y equals 6. And we can check that real quick. If we go back and plug in both of those values, we will see that both of our values, or both of our equations, will end up giving us true statements. So we'll plug it in real quick just so we can see it's done. Make sure we've got it solved. I'm going to do 6 equals 2 times x, which is 1, plus 4. So all I did was take this equation here and plug in my points 1 and 6. So I've got 6 equals 2 plus 4. 6 equals 6. That is true. And we'll check with the second one real quick. We have 3 times x, so 3 times 1, plus y, which is 6, equals 9. We can see here we just took this equation and plugged in my 1 and my 6 for x. 3 plus 6 equals 9. 9 equals 9. Again, that's true, so we can see we verified for both of those equations that that is in fact the correct answer. Now, sometimes we're given a system of equations and it isn't solved for us. So really all we have to do is we have to decide what variable to solve for. And we want to make that decision by looking at the possible variables we can solve for. And we want to look for the easiest one to solve for. So if I'm looking at my variables, I have a 2x, I have a negative 3y, I have a 4x, and I have a positive y. The easiest ones to solve for is going to be any variable that has a coefficient of 1. The only one in this case that has a coefficient of 1 is going to be my y here. So what I'm going to do is I'm going to solve for y in the second equation. To do that, I'm just going to subtract 4x on both sides. So my solved equation is y equals 24 minus 4x. And remember, that was my first step where I isolate my variable. Sorry, that's a 4. Okay, so I've got this solved. I solved for y. What I'm going to do now is in my equation up above, I'm going to take this 24 minus 4x and I'm going to plug it in for y. And this is going to be a good example because this is going to be a problem that has some factors that we could easily miss if we're not paying attention. So we've got 24 minus 4x, and the whole thing is, we got equal to negative 2. Alright, so now we're just going to solve just like any other any other equation that we've solved for. First thing we're gonna do, we're gonna distribute. Better get moving. First thing we're gonna do is to distribute. So this negative 3 I'm gonna distribute to both of my numbers here. Negative 3 times 24 is negative 72. Negative 3 times negative 4 is positive 12. And I still have my x on there. My 2x didn't change. My negative 2 didn't change. If I combine these 2x and 12x gives me 14x. So I have negative 72 plus 14x equals 2. One more step I'm going to do before I move this problem over to the right is I'm going to add 72 on both sides. So I've got 14x is equal to, what's that got for me? 74. Okay, so as we're looking through here, divide both sides by 14, divide by 14. These are going to cancel out. I've got x equals 74 over, oh, you know what? This is what I did wrong. I didn't bring down my negative here. So that should actually just be a 70. So I should have 70 divided by 14. Make sure we're being very cautious with our signs, which looks about a lot better. So I have 70 divided by 4, which is going to give me a value of 5, which is great. So we did all that work, and we found that x equals 5. So I'm going to erase this work now so we can finish this problem. So we got x equals 5. Now we have to solve for y. I'm going to look back at my original equation here where I had y equals 24 minus 4 times x. I'm going to rewrite it. 24 minus 4 times 5, because I plugged in my 5. Now, pretty simple. 24 minus 20, which gives me a value of 4. So I know that x is equal to 5, y is equal to 4. So for our substitution, really there's 3 main rules we want to follow. First rule, we want to isolate a variable and pick the easiest variable. We don't want to work harder than we have to. Should put an A in there. So that's my first rule. Second rule, once I isolate a variable, plug it in and solve. And then the third thing I'm going to do, once I solve for one variable, I'm going to plug into original to solve for second variable. Okay? And that's how I end up solving 5, 4. Now if I were to graph these with our graphing method, I'm going to see that those two lines intersect at 5, 4, which again just reinforces the answer for me. Just another thing that I can use to prove that that is the correct solution.